So guys, welcome to our channel once again. In today's video, we have here these 10 questions to answer on the topic water. So in short, stay till the end of this video. So let's start with the first question here. It says, a major process involved in the softening of hard water is A. Oxidation of calcium atoms to its ions. B. Conversion of soluble calcium salts to its triisocarbonate form. C. Conversion of an insoluble calcium salts to its triisocarbonate form. D. Decomposition of calcium triisocarbonate form. So guys, the answer to this question will be option B here. That's conversion of a soluble calcium salt to its triisocarbonate form. So let's consider the next question, question number 2 here. It says, which of the following is a hygroscopic substance? We have NaNO3, B, CaCl2, C, MgCl2, and D, FeCl3. So, guys, the correct answer to this question is option A, and that's NaNO3. That's sodium trioxonitrate 5. So, the sodium trioxonitrate 5 is a hygroscopic compound because it's a substance that can absorb moisture from the atmosphere while it still remains the same. So let's consider the next question, question number 3 here. It says, on exposure to the atmosphere, a hydrated salt loses its water by crystallization to become anhydrous. This phenomenon is referred to as A. Efflorescence, B. Hydrolysis, C. Deliquescence, D. Hygroscopy. So guys, the answer to this question is option A, and that's efflorescence. Actually, efflorescence is the process through which hydrated salts lose all or part of their water by crystallization to the atmosphere. So let's consider the next question, question number 4 here. It says, the method that can be used to convert hard water to soft water is A. Passage over activated charcoal, B. The use of an ion exchange resin, C. Chlorination, D. Aeration. So guys, the answer to this question is option B here, and that's the use of an ion exchange resin. So the use of an ion exchange resin is a method that can be used to convert hard water to soft water. So this process is used to soften water by exchanging the magnesium and calcium ions in the water with sodium ions. So that's it for that question. The next question here is question number 5. It says, steam changes the color of anhydrous cobalt 2 chloride from A. White to green, B. Blue to pink, C. White to red, D. Blue to white. So guys, the answer to this question is option B, and that's blue to pink. So let's consider the next question, question number 6. Sources of water includes the following except A. Well water, B. Spring water, C. Acid water, D. Rainwater. So guys, the answer to this question is option C, that's acid water. So let's consider the next question, question number 7. It says, hardness of water is caused by the presence of the ions of A. Sodium and potassium, B. Calcium and sodium, C. Magnesium and silver, D. Calcium and magnesium. So guys, the answer to this question is option D, calcium and magnesium. So let's consider the next question, question number 8. The chemicals used to soften hard water involve the addition of A. Insoluble sodium compounds, which form insoluble precipitates of calcium and magnesium ions. B. Soluble sodium compounds, which form soluble solutions of calcium and magnesium ions. C. Soluble sodium compounds, which form insoluble precipitates of calcium and magnesium ions. D. Insoluble sodium compounds, which form soluble solutions of calcium and magnesium ions. So guys, the answer to this question is option C here. The chemicals used to soften hard water involve the addition of soluble sodium compounds, which form insoluble precipitates of calcium and magnesium ions. So let's consider the next question. Question number 9 here. It says the percentage of water of crystallization in zinc tetraoxosulfate 6 heptahydrates is A 87, B 33%, C 44%, and D 55%. So guys, a simple way to go about this is just to calculate the molar mass of this zinc tetraoxosulfate 6 heptahydrate. So when you calculate the molar mass of this zinc tetraoxosulfate 6 heptahydrate, then you also have to calculate these 7 molecules of water. That's the molecular mass of these 7 molecules of water. So the percentage of water will now be the molar mass of the water over the entire molar mass of the solution, then times 100. We can actually do this together here. Look, let's just simply zoom into our workspace here and do this together. So zinc has an atomic mass of 65. So let's say 65 plus sulfur is 32, then plus oxygen is 16. 16 times 4 is about 64, and then this will be added to 7H2. So 7 times H2, H is 1 times 2, that's 2 times 7, that's 14 here. And then oxygen is 16, and 16 times 7, that's 112. So this will be, let's add all these together. So this will be 287. So, but for water alone, that's 7 molecules of water. All we just have to do is to add the 14 to the 112. That's the 7 hydrogen to the 7 oxygen. So this will give us 126. So it's the 14 plus 112 is 126. So 7H2O is this, and then ZnSO4 7H2O is this. So now we've gotten the two. We're going to, for us to calculate the percentage of water, we're going to do that of water, that's the molecular mass of water, over the total molecular mass of the compound, that's ZnSO4 7H2O. Then all these times 100. So with this, that's 126 over 287 times 100. So this is 126 over 287, then times 100 here. So guys, the answer here is 43.9. That's approximately 44%. So guys, that's option C here, and that's the answer to this question. So let's consider the next and the last question, guys. That's question number 10 here. It says, which of the following substances is not hygroscopic? We have A, salt, B, sugar, C, aluminium, D, silica gel. So guys, the answer to this question is option C, and that's aluminium. Aluminium is not hygroscopic. It does not have a strong affinity for water vapor and does not absorb moisture from the air. So guys, that's the answer to this question. This is where we'll end this video, guys, for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not a subscriber. If you have any specific question regarding this video, guys, you can drop your question on the comment section below and we'll ensure to give you a response. So guys, we also want to encourage you to join our YouTube channel community by hitting the join button below. So thank you once again for watching this video and see you on the next one.